Folks, how y'all doing? Yesterday I was kind of bored and had to build myself a little project, and basically what I built was a 5 volt regular 5 volt adjustable regulated power supply with a digital readout. I used the LM317 adjustable voltage regulator right here. That's the basic circuit I use for the actual power supply section up here. AC cord, got the plug, fuse, transformer, full wave bridge rectifier, electrolytic capacitor, 12 volt regulator, which feeds the voltage or the voltage display, and then I built this adjustable LM317 adjustable voltage regulator. So, yeah, I've built a couple of these in the past. I haven't got a whole lot of current out of them because basically the LM317, as it sits, is only good for about an amp, maybe an amp and a half, possibly, if that. So, this power supply is no different. Only it draws about an amp or so, basically because of the capacity of the voltage regulator. So I was thinking, as I was building the contraption, if I should add a 2n3055 current amplifier to the mix, to the output. I haven't got that incorporated yet, but I'm thinking about adding a 3055 or a couple of 3055s and boost the current a little bit on the power supply. But in any event, here is the critter that I put together yesterday. Of course, we got the power on and off switch right here. A binding post, positive, negative. That's the voltage adjust from 1 to 5 volts, and of course, voltage display. So I just plugged it in. Now we're going to turn it on, and you can see that she sits at 1.19, 1.2 volts. That's float voltage of the LM317. And then I can just bring the voltage up with the control to 4.95 and bring it back right down again. I know there's not much to look at, but hey, project's a project. The transformer I got is capable of putting 12 volts into the full wave bridge rectifier. So, we're going to peel the cover off of this power supply here, and we're going to show you the internal guts of this. As I was saying, the transformer outputs 12 volts to the rectifier at 2.5 amps. Now, I'm kind of perplexed how I can put 12 volts into the rectifier and only get a maximum of about 4.95 volts out. It's kind of strange, but anyways, let's pull her apart and have a peek inside. Okay, so we have the power supply. The back of the power supply just got AC input and fuse. So this is the back end of the front panel. We've got the potentiometer here for controlling voltage. We've got the eBay special voltage display right here. When you get these new, when you buy them, you get these are wired up. Let me get a pointer here of some sort. Get this lovely pointer here that John sent me. So you got ground here, and you got 2 positive inputs. When you buy this display direct from eBay, these 2 points here, these 2 red points, 2 wires, are usually bridged together. And as you can see, I have that separated on this one for very good reason. We've got the outside, or I'd say this wire here. This is actual voltage to the binding posts. Go to here, and supply voltage for the display itself is on the center pin, and then you got ground. So if you want to keep your display on, and still be able to see, like if you got a variable voltage display like this, and when you bring it all the way back to 0 and you still want the display to show 0, then you have the wire up display like this. So you got your voltage, your actual adjusting voltage to this pin. You've got your supply voltage for powering the display on the middle pin, and then you got your ground. That's how that's wired up. Kind of stumbled across that yesterday. So then we got a big bulky switch over here. Big old monster switch. Turn it on and off. Then we've got the transformer. It's, as you can see, 12.5 volts at 2.5 amps. So yeah, I got 12 volts going to the bridge rectifier, which is down here. Yellow is the is the AC into the bridge rectifier. Red is out and black is ground. So yeah, I'm putting 12 volts into it and getting 5 volts out. Kind of odd. Still trying to figure that one out, why it's doing that. The bridge itself could be bad, or there's something here drawing the voltage down, one or the other. In any event, so we got a filter capacitor right here, 35 volt, 8200 UF. In order to get this capacitor to fit into this holder, I had to fit it down into a cardboard tube and then wrap electrical tape around it to take up the space, and it actually holds very well. It's you know, it works. What else can you say? And then down here we have 2 voltage regulators. We have a 12 volt regulator here that supplies voltage to the display over here. Display is only been running 5 volt right now, because I'm not getting full 12 volts, 12 or 13 volts out of the bridge rectifier for some reason. And I disconnected the input here in here just to verify the voltage would come up on the rectifier, and it still don't. So it could be an actual issue with the LM317. I'm not 100% sure yet, but later today we're going to be disconnecting the input of the LM317 and see if the voltage comes up on the bridge. I think it could be a bad LM317. It's adjusting voltage, but I don't think it's doing it right, if that makes sense. I think there's something drawing down the voltage on the bridge rectifier, or it was either the regulator is bad or the bridge rectifier is bad. One or the other. Because this transformer can put out 2.5 amps. So I doubt very much it's a transformer issue. I did check the AC to the rectifier, and there is 12 volts, so the transformer itself is working fine. It's the output of it. But in any event, we'll worry about that later. But for right now, I'm just wondering now if I should put a 3055 in here to build up the current a little tiny bit. What do you think? Not a whole lot of space to put one. I can probably jimmy one down underneath the transformer here and have it on the outside here. Probably might be able to actually get 2 here. But that's my plan anyways. But we'll worry about that later with another update video. Anyways, I just want to show this little 5 volt. I'll call it 5 volt right now to figure out what's going on here. But she's 5 volt, a variable power supply. Anyways, what did you build out of your junk box today? I built a power supply. All the best, folks. Take care. Right, so I made a couple little changes there. I was going to end the video there before this one, but I said, what the hell, I'll troubleshoot this one. So basically what I've done, I've replaced the LM317 over here with another one I had. Seems to be drawing down less off the rectifier. And I've also changed out the rectifier right here and add another electrolytic capacitor. So now I'm still at 1.21 on the low end, and I can step her up to 5.42 now. Before, the highest I managed to get her was 4.97. So by changing out the rectifier, the LM317, and adding one capacitor, I managed to gain an extra half a volt roughly. So yeah, not too bad. The rectifier, there's 12 volts going into it, and there's about 11.6 volts AC, or I should say 11.6 volt DC coming from the rectifier, which feeds the voltage regulators. So yeah. Current amplifier might actually work here. But in any event, I managed to get her above 5.42. Get her up to 5.42 volts. Awesome. Now, to incorporate a 2n3055. And this is the next step, I suppose. Put her down on the bottom, down here I'm thinking, and see if we can't step the current up here a little bit. Okay, so I've added my 2n3055 as in the circuit here. Shows the 3055 is in on back of the power supply, right there. Now mounted, and it's actually cold to the touch, which is good. And right now, before I added this 3055, I was getting on the low end about 1.2 volts and high end at 5 volts. Well, now the way she's wired in this circuit here, the low end now is 7.5 and the high end is about 14.2 volts. So I guess we're going to find out if this power supply can handle a light bulb. I'm not sure if it's 12 volt or 24 volt, I'm not sure. But we're going to check to see what the current capacity of this power supply is based on a light bulb. And going with that there circuit. So before, when the power supply was doing 5 volts, I put this bulb on, it could just barely even light it. The filament would just barely glow. So now we got voltage stepped up due to that circuit. Now we're going to try it like this and see what we have, or what it can or can't do. Let's see. And you see the bulb lit up, but we got a voltage drop. A pretty big voltage drop. We're going from 14.2 to 4.8 volts. So safe to assume 3055 is not that working very well in that configuration, as you can tell. Bulb light is fairly bright, but it's too much of a voltage drop there. Way too much of a voltage drop. So, and the 3055 is getting a little bit warm, so she is passing current, or trying to pass current. But she haven't got the parts, she haven't got the guts. So we know it don't work in that configuration. So I looked online There was this circuit, which is what's done with her now. And then I come across another circuit, and the 3055 is in a different configuration, as you can see here. Instead of the complete output coming from the emitter of the 3055, it's shared between the emitter and the output of the LM317 through a 10 watt 10 ohm resistor. So we're going to try that configuration and see what that gives me, and hopefully it'll give me more voltage adjustment as well, because that's not a whole lot of swing, only about 5 volts there. She should be able to swing a lot more than that. And a 7.5, let's just for badness, let's put the bulb on her, just for badness. And she goes right down to 3 volts. Crazy. Anyways, let's wire her up and in this configuration and see if the 3055 can work any better like that. Alright, so we got our bulb connected to terminals. We've got the 3055 wired into this configuration at the moment. So let's turn it on and see how the power supply reacts now. So the lower end with the bulb 0.67, and now the high end is now 4.85 volts. Keep in mind there's now a 10 ohm 2 watt resistor in line. This is specified right here in the circuit to the output. And so we went from 14 volts to 4.8 volts at maximum voltage. So I'm going to jump out the resistor here and see what happens with the voltage. Let's bring her all the way down, connect her up. Now we're at 1.2. Let me bring her up to 5.48 volts. So the question remains, should I leave the 10 ohm resistor in or out? The resistor, as far as I know, is for limiting current back to the 3055. 3055, which is back here. It's not all that hot. Fairly cold actually. And the power supply just shut off. So I'd say we just pop the fuse. So there you have it. And there's the fuse. She indeed popped. She is a 1/16 amp 250 volt fuse. Let's see if we got a 3 amp fuse to put in here, because obviously if the transformer is trying to draw more than 2.5 amps, then obviously this little puny fuse here is not going to be enough to keep the transformer powered. So let's try replacing this fuse. It's got a 1.5 amp fuse in there now, and I don't have the resistor jump this time. The wire's still in my hands here. Let's see how she performs under load. Keep an eye on the transformer here. current. Shouldn't get too warm here. Still at 4.87. Haven't dropped. Haven't dropped. Transformer's cool. 10-watt resistor is cool. 2n3055 is just very, very lukewarm. 12-volt regulator is good. The LM317 is good. Transformer still cool. Still cool. Transformer's just a little bit just warm. Hardly feel it. .3055 is starting to get a bit warm. It's not overly bad, but it's starting to warm up there. Looks like we're good. Let's check the voltage on the rectifier. If I get my probes out here. There we go. Rectifier is outputting 15.9 volts all day long, no problem. Filter capacitor terminals is 5.47. And let's see what the difference in voltage is between that digital display there and my multimeter. Multimeter shows 4.89 and that voltage display shows 4.89. So the voltage is good. A lot of wires like to get tangled up and everything. Yep, 15.95. .055 starting to get a little bit warm. Not overly hot, but a bit warm. The 10-watt resistor is nothing to that. That's still cold. And transformer still pretty cool. So I'm thinking we're good. Wouldn't mind increasing the voltage here at 4.90, because before, the way the 2n3055 was wired in. We had lots of voltage but no current behind it. Now we've got current but lower voltage. I guess there's a give or take there when it comes to this stuff. Everything's still nice and warm. Warm that is. Transformer is just hardly noticeable. Wiring is cold. I think we're good. The better question is now is should I keep this resistor in line or not? This white 10 ohm 10 watt resistor. When I bypassed it, it popped a fuse pretty quickly. But with it in line, it's not popping the fuse. Now the fuse I got in there now is an amp and a half, 1.5. Cool. So boys, one question I gotta ask you. What'd you build out of your junk box today? By the way, based on this circuit here, if anybody has an idea of how to step up the voltage on the output to 12 volt, I'd like to hear from you. And if you got a circuit diagram that's pretty close to this and I can easily fit it inside this box enclosure, by all means send me an email at via1mds@hotmail.com. Anyways, have fun folks. Gotta be at something on a wintry, snowy evening. 363 out.